Hello, and welcome back to Every Problem. This is Stewart Calculus, 8th edition, section 1.1, problem 49. And with this problem, we're told to sketch the graph. And here we have f of x equals, well, there's quite a bit there. This is what's called a piecewise function. And although it looks a little bit intimidating, really a piecewise function is just your standard function, except instead of one rule, like x squared or x plus 1 or something, instead of one rule, you have two rules, and all you have to do is just read it pretty carefully and it should all fall into place. So if we just take a moment and we read it, and we see f of x equals, well, it equals absolute value of x if the absolute value of x is less than or equal to 1. So what does that mean? That means that, let's see, if we were to make a table of values, which can be really helpful to just simplify things a little bit as we think through certain problems. We have x, our input, on one side. We have f of x on the other side. So they're saying the rule is absolute value of x if the absolute value of x is less than or equal to 1. Well, what's something we know about absolute values? Luckily, I'll put a little asterisk here, and I'll say what we know about absolute value x. Well, we know that it cannot be a negative number. So that's very helpful. That's very helpful because we know that it has to be between 0 and 1, and especially because it says less than or equal to 1. So what we know is that for our f of x, that's only the rule from 0 to 1, because absolute value of x cannot equal a negative number since it's the absolute distance, right? Then, if the absolute value of x is greater than 1, then f of x just equals 1 and nothing else. So what does that look like? Well, how about this? Let's just put some numbers in first with our table of values, right? And we'll kind of think it through. So let's say we have -3, -2, -1, 0, 1, 2, and 3. I'll kind of box this off here. There we go. Okay, so if we have that, well, -3, let's see. If we take the absolute value of -3, we get a +3. So let's see, I'll write it over here. Absolute value of -3 equals +3. So what do we see? We see that it's greater than 1 right here. So therefore, f of x is going to just be equal to 1. Same thing with -2. Absolute value of -2 is equal to 2, which happens to be greater than 1. And so our rule states that if the absolute value is greater than 1, then our answer is going to be 1, and that's it. So this is nice because this is smooth and straightforward so far. It's kind of weird to think in that sort of way. It can be kind of weird and backwards to think about all these absolute values and greater than, equal to, but really the key is just to work nice and slowly and patiently through it, very patiently, and it just comes together nicely. So now if we go to -1, let's take the absolute value of -1, and that just gives us 1. So if we look back up at our rule, at our piecewise function, if it's less than or equal to 1, then our answer is absolute value of x. So coincidentally, that does happen to just be 1 as well. 0, let's see. 0 well, that's just 0, and it's not greater than 1, so that's going to be 0. What happens if we plug in 1? Well, that's going to be 1 because the same thing, right? Absolute value of 1 is equal to 1, which is going to be equal to absolute value of x, which is all 1s, so it's just 1s all over the place, right? So we'll plug in a 1 there. What about 2? Next value, absolute value of 2. Well, that gives us 2, which is greater than 1. So that's going to be 1, and as you can see with the pattern, right, when we plug in 3, the same thing is going to happen. We'll get 3, which is greater than 1. So because of that, our rule tells us that our y value is going to be 1. So lots of 1s, a 0, and then some more 1s. But here's something interesting about this graph. When we start to plot the graph, I'll redraw that line. That's a little bit sloppy, but that's a pretty straight line. Okay. So what do we have? We have, I'll do these by 2s, just so we have a little bit more defined of a graph. There we go. So we have -3, -2, -1. That's 0, 1, 2, 3. Okay, at -3, this is 2, this is 1. At -3, we had 1. At -2, we had 1. -1, we had 1. 0, we had 0. 1 was 1, 2 is 1, 3 is 1. Okay, so everything pretty much just looks like it's 1, except for this general area here that I have circled. So what goes on there? Well, let's try it. Just really quickly, this shouldn't take too long. Let's try it with 0.5 and -0.5. So if we were to input, let's see, absolute value of -0.5, that gives us 0.5. And that is less than 1. So we're going to go with our first rule, which is just absolute value of x. So absolute value is going to be 0.5. As well, if we did absolute value of 0.5, we get the same answer. So it looks like for both x values, -0.5 and +0.5, we're going to get 0.5 either way. So let's go ahead and put those dots in, and we see that what the general trend is for this function. Let's go like this. So we get this kind of strange looking graph where it first starts out looking like your standard absolute value function, right? If we zoomed in a bunch, you would say, yes, absolute value. But as we zoom out, we do see that it flattens out on both of these sides here. And that's what the graph looks like for problem number 49.